Hello everybody and welcome to another session. Let's go for the older folks. My name's Les Thatcher. Hope you're all well. Today we're carrying on with MicroPython. And I don't know if you can remember, in the last session we looked at digital and analog inputs. When we pressed the button, the LED came on, that's the digital side. And we had a potentiometer where we turned the potentiometer slowly one way or another, and that brightened and lowered the brightness of the LED. Well, today we're going to do this very simple. We're going to automate it. We're going to automate it within the sketch. Now, what I'm going to do, let's come over. We're going to do a quick little circuit. Now, just a reminder, if you haven't got all your components, all your parts, I've got a link down below, an affiliate link. If you click on that link, they do have an ESP32 kit that you can get. And you'll get everything you need to do the sessions that we're going to be doing during this MicroPython playlist. All right? So here's our circuit, simple little circuit. We've got our LED, all right? Put the long leg on the right hand side. Remember, it's got two legs, one longer than the other, just like our fingers. Goes on the right hand side. Get a cable. I've used a blue cable in this case, and go to pin 5. Simple. Go to a pin 5. Left hand leg, 330 ohm resistor, goes over the channel. Right, remember this channel is not connected to the rest. All right, so we've got 5, nothing, 5. Over the channel. Goes from the other end of the resistor to our ground rail. Let's go now over to our IDE. Okay, our Sony IDE. Right, and here what you want to do is just open it up, and we want main.py. Right, so what we're going to do, we're going to generate a PMW signal with our ESP32 using MicroPython firmware. And what we're going to do, we're going to dim and change the brightness of an LED. And that's called, we're going to change the duty cycle, right, over time. Okay, so far. Now, simple little code, very simple little code, right? But I just wanted to show you how we can do it both sides by using a potentiometer and using the circuit, all right, or the sketch, the sketches. So, from machine, import pin, capital P on the pin, comma, space PWM, telling it we're using pulse width modulation. And that's our first line of code. From machine, import pin, comma, space PWM. From time, import sleep. Right, because we need the sleep command during this sketch. Now we're going to set the frequency, right? The frequency. So frequency base equals 5,000. Rightio? Frequency equals 5,000. Now we're going to name our pin. All right, so it's LED equals PWM capitals, pulse width modulation, brackets on, pin, capital P on the pin, okay, brackets on, 5, brackets off, right, comma, base, and then it's frequency again, right? Okay, comma, frequency, and it's brackets off. Notice our brackets change colour, right? Our brackets change colour. enter, enter. Now we want a while true loop, okay, a while loop. All right, so it's while. Wouldn't be so bad if I could spell, would it? While, space true, capital T on the true. Colons, remember what happens when we put a colon in? Auto indent. For duty, for space, duty, underscore, cycle, space, in, range, brackets on, and we want the range between 0, comma, space, 1024. Brackets off, colons, enter. Right, for the duty cycle, in range, brackets on, 0, comma, space, 0, 1024. What have I put? 2, 3. Change that quickly. 2, 4. Remember, colons, enter, gives us our auto indent. Our auto indent. Then LED dot duty, brackets on, duty underscore cycle, and it's brackets off. Right, for duty underscore cycle in range, 0, comma, 1024, LED dot duty, brackets on, duty underscore cycle, brackets off. And now we need a sleep. Remember, sleep is always done in milliseconds. And it's brackets off. All right, so that's our simple little code. What I'm going to do, I'm just going to file and I'm going to save that. See the save box come out. Let's just quickly go through the code. We've done this before. From machine, import pin, class. So we've imported the class and we've told it we want a pulse width modulation. Then we want to, this here, we create the object. LED equals PWM on pin 5. Right, and then if we come down here, right, we got the duty cycle in range. Okay, we can set a range from 0 to 78125. We set ours at 5,000 hertz. Right, and then the while loop. Right, we've created the for loop, right, and what this does, this will increase the duty cycle by 1, right, for each loop, okay, and with an interval of 5 milliseconds. All right, so what I'll do, that'll start, stop, then step. Okay, start, stop, and step. Okay, and then in each loop, the LED's duty cycle to the current duty cycle value. So that's what that line is there. Right. Okay, we've saved it, and that's just under here. Let me go to ahead and let's have our fingers crossed. I'm going to on the, let me just make sure you can see what I'm pressing. The green button, run a current script. Okay, I'm running the current script. Let's go to our Raspberry Pi 5, my IDE. And there we go. It's bad if I could get it. What's the LED? See it changing? You might not be able to see it very well, but it starts slow and gets brighter, brighter, brighter and brighter. All right? And that's how we changed the duty cycle within the sketch of our Sony IDE. As I say, it was a quick little one, but we needed to understand how we write that sketch. Right, we needed to understand that. And as we build on our knowledge, we'll be bringing a lot of this in together and integrating it. All right. So anyway, thanks for watching. Please give us a thumbs up, subscribe, and I'll see you in the next session. Bye-bye.